Hello there, and welcome to the Sleepy Astronaut channel. I'm so glad you found your way here tonight. Maybe it's been a long day, or maybe you're someone who simply enjoys drifting to sleep with quiet wonder, letting the vastness of the universe soften the edges of thought. There's nothing you need to do now but rest. Let your breathing slow, your mind loosen, and your body grow warm and still. Because tonight, we're taking a gentle journey through the story of the James Webb Space Telescope, a golden eye adrift in the deep night of space. From the dreams that led to its creation to the galaxies and newborn stars it has revealed, we'll explore 100 sleepy facts to help you unwind, relax, and drift toward the stars. And if these calm explorations bring you peace, feel free to like the video and subscribe. It helps other sleepy travelers find their way here too. Now, close your eyes and let's begin. Fact 1. The telescope. Born from wonder. Long before the James Webb Telescope floated among the stars, it existed as a quiet idea, a hope to see deeper into the universe than ever before. Scientists imagined a telescope that could look not just at planets or galaxies we already knew, but at the universe when it was young, barely awakened, still learning to shine. This dream began in the 1990s, as engineers and astronomers wondered what secrets the earliest light might hold. They believed that if we could just gather the faintest glow, we could glimpse our own cosmic beginning. And so, slowly, patiently, the dream took shape. One golden mirror at a time. Beyond that first spark of wonder, another thought was waiting in the dark. Fact 2. A collaboration across time and nations. The James Webb Telescope was not built by one person, or one country, or one moment in time. It is the result of decades of shared curiosity, a collaboration between NASA in the United States, the European Space Agency, and the Canadian Space Agency. Thousands of engineers, scientists, mathematicians, and quiet dreamers contributed. Some designed mirrors. Some tested folding mechanisms. Some spent years calculating how to cool the telescope without disturbing it. Many never met each other, yet they worked as one. It is a reminder that knowledge grows best when shared, like light spreading gently across the night sky. And with so many hands guiding it, the telescope's purpose began to clarify. Fact 3. A mirror to catch ancient light. The James Webb Telescope was built to observe infrared light, the kind of light that travels softly through dust and distance. When the universe was young, its first stars and galaxies glowed faintly in this spectrum. Over billions of years, that light stretched and cooled as the universe expanded. Now, it arrives at Earth like a whisper, delicate, ancient, and easily lost. Webb's golden mirror was crafted to catch that whisper, to not just see stars, but to see the first stars, to not just study galaxies, but to glimpse their earliest forms. It is, in essence, a time machine made of gold and silence. And with that purpose understood, the story of how it was built begins to unfold. Fact 4. The cosmic question. It was built to ask. At the heart of the James Webb Telescope lies one quiet, profound question. How did everything begin? Not just the beginning of Earth, or the Sun, or even our own galaxy, but the beginning of the first light that ever shone. Scientists call this era the cosmic dawn, a time when the universe was still dark, quiet, and filled with cooling gas. Slowly, the first stars flickered into existence, illuminating the vast silence. Yet these earliest stars are so distant, their light has stretched into faint infrared waves. Only a telescope designed to see in that deep, gentle wavelength could ever find them. Webb's mission is to listen for those earliest cosmic heartbeats, the first glimmers of illumination in an endless night. And once this purpose was known, the telescope could begin to take shape. Fact 5. Why we needed a successor to Hubble before Webb. The Hubble Space Telescope changed our understanding of the universe. It revealed star nurseries, colliding galaxies, and the quiet beauty of nebulae. But Hubble sees mostly visible light, the light our own eyes are tuned to. The early universe, however, has been dimmed and stretched by time. Its glow now lives in the far infrared. To see the youngest galaxies, we needed a new kind of instrument. Webb was built not to replace Hubble's wonder, but to look deeper, earlier, and softer, like someone closing their eyes to sense a memory rather than see an image. The two telescopes complement each other, like two storytellers sharing different chapters of the same cosmic tale. Hubble shows us what exists now. Webb shows us where it all began. And so, the need for a golden mirror became clear. Fact 6. The quiet patience of space science building. Webb required patience beyond ordinary time. From concept to launch, more than 30 years passed. During that time, people who began the project as young engineers retired before seeing it complete. Others joined long after the first blueprints were drawn. The telescope became a generational effort, a relay of knowledge handed gently from one set of hands to the next. Pieces were tested for years in chilled vacuum chambers to ensure they could survive the deep silence of space. Every bolt, hinge, and reflective surface was checked, and checked again. Because once Webb launched, there would be no repairs, no astronauts to adjust it, only the cold distance of space. Science, at times, is not about speed, but devotion. And with devotion, Webb slowly grew into the telescope we now know. Fact 7. A telescope made for the deep past. Unlike most telescopes pointed at the sky today, the James Webb was built specifically to look backward in time. When we gaze across space, we are also gazing across history. Light takes time to travel, so the farther away something is, the older the light we see. Webb is tuned to detect the faintest, most ancient traces of light. Light that began its journey more than 13 billion years ago, when the universe was still young and unsure. To observe something so delicate, the telescope must stay incredibly quiet, incredibly cold, and incredibly steady. It does not capture bright objects or dramatic events. Instead, it listens for whispers, soft glimmers from a universe still forming itself. In this way, Webb acts not as a spotlight, but as a candle illuminating memory. With each small flicker it receives, we learn a little more about where we came from. Fact 8. The idea of seeing first light. Astronomers use the phrase first light to describe the moment the universe began to glow. Before that, everything was dark, filled with gas and potential, but no stars to shine. When the first stars ignited, they transformed the universe forever. Their light spread outward, touching the dark with warmth and clarity. But that light has traveled such an immense distance that by the time it reaches us, it has stretched and faded into the deep infrared. To see it, a telescope must act like a gentle net, catching the faintest patterns. Webb was built to do exactly this, to observe the soft, ancient glow of stars long gone. In these glimmers, we find the beginning of every atom in our bodies, every planet, every heartbeat. To see first light is to see the earliest echoes of ourselves. Fact 9. The the search for hidden galaxies. Before Webb, the earliest galaxies we observed appeared small, dim, and simple, mere clusters of faint stars. But astronomers suspected there were more hiding beyond what our instruments could detect. A telescope with infrared vision could see through dust, distance, and time itself, revealing what was once invisible. Webb's first deep images confirmed this suspicion. The universe's early years were not quiet or empty. They were full of vibrant, newborn galaxies, glowing softly in the dark. Some were surprisingly large, some beautifully irregular, all shaped by forces we are only beginning to understand. This discovery added complexity to the story of cosmic dawn, a richer, more intricate beginning to everything. And quietly, the telescope continues to uncover more, one glimmer at a time. Fact 10. The hope of understanding our origins. The James Webb Telescope is not simply a machine for gathering data. It is a way of asking a very human question. Where did we come from? Every atom in our bodies was born in stars that lived and died long before the Earth was formed. The calcium in our bones, the iron in our blood, all of it once glowed inside distant suns. To understand how stars first formed is to understand how we came to be. Webb allows us to trace this story not in imagination, but in real light. Light that has traveled billions of years to meet us. When we look at its images, we are not just observing distant galaxies. We are looking at the long, quiet path that led to our own existence. And in that realization, there is a comforting sense of belonging. Fact 11. The golden mirror design. At the heart of the telescope is a golden mirror, wide and gentle, shaped not as a single piece, but as 18 hexagonal segments. Each piece is coated with an ultra-thin layer of gold, just a whisper of metal, chosen because gold reflects infrared light with exceptional clarity. This mirror functions like a calm, open hand, collecting ancient light. The hexagon shape allows the mirror to fold for launch and then open like a flower in space. Once opened, the segments are aligned with extraordinary precision, each one adjusted to a fraction of the width of a human hair. When the mirror is perfectly aligned, it acts as one seamless surface, catching light older than the Earth itself. It is both engineering and poetry, a golden blossom floating in the quiet dark. Fact 12. Why beryllium was chosen. The mirror's core structure is made of beryllium, a lightweight metal unlike any other. In the freezing cold of deep space, most materials shrink or warp, even by the smallest amount, which would distort the telescope's vision. But beryllium remains stable and calm, holding its shape even at temperatures near absolute zero. It is strong, yet gentle, resilient, yet delicate. To work with beryllium requires careful craftsmanship and time. Each mirror segment was polished again and again, tested in chilling vacuum chambers to ensure nothing changed under cold conditions. In a way, beryllium mirrors the purpose of Webb itself, to remain steady, silent, and precise, even in the vast stillness of space. Because only with such steadiness can we see the universe clearly. Fact 13. The beauty of the honeycomb. Shape. The mirror's honeycomb pattern was chosen not only for engineering efficiency, but for elegance and function. Hexagons fit together without gaps, creating a wide, unified surface that can expand or fold with quiet precision. In nature, bees discovered this shape long before we did. It is the most efficient way to fill space, strong yet lightweight. By mirroring nature's wisdom, Webb became both practical and poetic. Each segment holds its own place, yet works seamlessly with the others. like voices in a softly humming choir. When sunlight glances across the telescope, the hexagons glimmer like golden tiles of a celestial mosaic. This design reminds us that the universe often solves problems with grace, and that sometimes the simplest shapes reveal the deepest harmony. And as the mirror took form, another essential part of the telescope began to unfold below it. Fact 14. The sun shield, the size of a tennis court. Beneath the mirror lies Webb's vast sun shield, a layered, silvery sail that stretches as wide as a tennis court. Its purpose is quiet but vital: to block the heat and light of the sun, earth, and moon, allowing the telescope to stay cold enough to sense faint infrared light. The sun shield is made of 5 whisper-thin sheets, each thinner than a human hair. They reflect and radiate heat away in slow, gentle layers, like veils of cool moonlight. Without this shield, the telescope would warm ever so slightly, and the ancient light it seeks would fade into background glow. Deploying the sun shield was one of the most delicate steps of the mission, a slow unfurling in the vacuum of space. It opened like a silver flower, blooming quietly in the dark. Fact 15. Folding a giant for space travel. One of the greatest challenges of Webb's design was that it was too large to fit inside any rocket fully assembled. So the telescope was built to fold, its mirror panels tucked inward, its sun shield wrapped tight, its supports drawn close like gentle wings held to the body. During launch, Webb rested in this compact form, silent and waiting. Only once it reached space did it begin its slow unfolding, a sequence of movements rehearsed countless times on Earth. Each hinge, latch, and motor had only one chance to function correctly. There was no second try, no repair mission waiting. And yet, the telescope opened flawlessly, piece by piece, like a golden origami masterpiece, remembering the shape it was always meant to become. From this unfolding, the journey truly began. Fact 16. Cryogenic silence, operating at 233 degrees Kelvin. To see the faintest ancient light, the James Webb Telescope must remain extraordinarily cold, colder than anything on Earth can naturally be. Its instruments operate at around 250 Celsius, just a few degrees above absolute zero, where molecular motion nearly stops. At warmer temperatures, the telescope itself would glow in infrared light, overwhelming the delicate signals it is trying to detect. So, Webb exists in cryogenic silence, shielded from warmth by its great silver sun shield. In this cold, its mirrors do not tremble, and its sensors do not stir. The universe reveals itself in whispers, soft signals, faint beams stretched thin by time. To see further, Webb had to learn to be still. In the deep quiet, the first stars speak. Fact 17. Infrared eyes to see the invisible. Most of the universe is hidden from ordinary sight. Dust clouds scatter visible light, obscuring stars as they are born, and distance stretches ancient light into gentle infrared wavelengths. The James Webb Telescope was built to see in this spectrum, to reveal what is softly concealed. Infrared light slips through cosmic dust like warm breath through mist. It shows us stars forming inside nebulae, planetary disks swirling into worlds, and galaxies emerging when the universe was young. Webb does not look at the cosmos as our eyes do. It sees what lies beneath, behind, and before. Its sensors read the glow of heat and time, uncovering structures shaped in silence. Where our vision ends, Webb's begins, opening doors into realms we have only imagined. Fact 18. the cameras that catch ancient fire. To capture the universe's faintest light, Webb carries several carefully crafted instruments, each one tuned to read a different layer of meaning in the stars. Narration, which sees newborn galaxies and infant stars. Miri, which reveals dusty worlds, glowing nebulae, and forming planets. Spec, which spreads light into spectra to read the chemistry of distant skies. FGS Nearis, which helps the telescope hold its gaze steady and search for exoplanet atmospheres. Together, these instruments act like a choir of quiet observers, each listening to a particular note of the universe's song. They do not rush, they do not force. They simply receive the light, the color, the shape of time's oldest memories. In their patience, the cosmos unfolds. Fact 19. The engineers who never gave up. Behind every polished mirror and carefully folded panel are thousands of people who devoted years of their lives to Webb's creation. Some spent entire careers working on just one mechanism: a latch, a hinge, a cooling line. Others tested equipment in chambers colder than deep space, watching frost form on metal as faint echoes of infrared light were measured. There were moments of doubt, redesigns, setbacks, funding pauses, and long stretches where progress moved slowly. Yet the people who built Webb continued forward, not for recognition, but for the quiet belief that understanding the universe is a gift to everyone. Many would never see Webb launch, but their work traveled with it into the dark. The telescope is not just made of metal and gold, it is made of patience. Fact 20. The launch on Christmas morning. On December 25, 2021, while many people around the world were waking slowly into a holiday morning, Webb began its journey into space. It rode atop the Ariane 5 rocket from a launch site in French Guiana, rising gently into a bright, pale sky. There was no dramatic explosion, no roar of cinematic fire, just a steady ascent, like a slow exhale. For those who watched, the moment felt serene, a quiet culmination of decades of effort. As the rocket climbed, the telescope remained folded within it, like a golden blossom waiting for spring. There was a collective pause, a breath held, as it separated from the rocket and drifted freely into the night. In that soft moment, humanity sent a dream into the stars. Fact 21. Riding the Ariane 5 into dawn. The Ariane 5 rocket was chosen for its reliability, a gentle, stable launch vehicle known for precision and calm flight. Webb did not need speed or force. It needed steadiness. As the rocket carried it higher, the Earth curved away, blue and luminous. The telescope experienced no shaking deployment or sudden motions, only gradual release. It was as if space welcomed it, offering a quiet cradle for its unfolding journey. From there, Webb did not head toward the moon or orbit Earth. Instead, it began traveling toward a silent gravitational harbor nearly 1 million miles away, a place of balance and stillness, where the sun, Earth, and telescope share a delicate, stable dance. It was the beginning, not just of travel, but of transformation. Fact 22. The delicate dance of deployment. Once the James Webb Telescope was released into space, it did not simply begin observing. It had to become itself. Every part of the telescope was folded tightly for launch, like a flower bud held close. Over days and weeks, each mechanism was commanded to open, shift, or lock into place. This was one of the most complex deployments ever attempted. More than 300 single points of failure, tiny steps, where, if anything went wrong, the telescope could not function. And yet, the unfolding happened slowly, gracefully, like something remembering its own shape. Engineers watched each step from Earth, whispering encouragement across millions of miles, though no sound could travel in the vacuum of space. Piece by piece, Webb stretched its limbs into the starlight, and the flower began to bloom. Fact 23. The unfolding of the mirrors. The mirror segments, tucked inward at launch, now needed to open like golden petals. Each one rotated outward on precise hinges, then lifted into alignment. This movement required an almost unimaginable level of precision. The mirrors were adjusted with micromotors, each capable of shifting a single segment by distances smaller than the thickness of a sheet of paper, so small that we cannot sense it with touch alone. Slowly, the mirror took its full shape, a wide, open eye gazing into infinity. But aligned segments alone were not enough. The mirror needed to be curved perfectly, like a calm bowl designed to gather starlight without distortion. This shaping took weeks, guided by starlight itself. The telescope literally sculpted its own vision in space. Fact 24. Releasing the sunshield petals. The sunshield began as tight, folded layers, held in place by delicate restraints. Releasing it required Webb to unfurl 5 shimmering sheets, one after another, each guided by thin, graceful booms that extended outward. The sunshield did not snap open. It glided, unfolding slowly over several days. Each layer separated by carefully measured distance, allowing heat to escape into the cold of space. With every inch of expansion, the telescope grew quieter, cooler, more attuned to ancient light. From Earth, it appeared like a silver lantern opening in the dark, a guardian shielding the golden mirror from warmth. Once the sunshield was fully stretched and tensioned, Webb entered the temperature of deep time. Its vision was almost ready to awaken. Fact 25. A month-long journey to L2. After launch, Webb traveled for nearly 30 days to reach its new home, a point in space known as Lagrange Point 2, or simply L2. This place is not a destination in the usual sense. It is a balance. Here, the gravity of the Earth and the Sun pull in just the right way to allow Webb to orbit quietly, without burning much fuel. The telescope drifted farther from Earth, past the Moon's distance, into a region where our planet became a pale, distant sphere. This journey was not rushed. It was calm, like a leaf floating across a still pond. Each day, Webb grew cooler, quieter, more attuned to the faint whispers of ancient light. When it arrived at L2, it did not land. It settled into a gentle orbit, like a feather finding place in the air. Fact 26. The Lagrange Point, a quiet harbor. Tsau is a peaceful location, a kind of cosmic harbor. From here, the Sun, Earth, and Moon always sit on the same side of the sky, allowing Webb's sunshield to block all 3 at once. The opposite side of the telescope faces outward into the deep, open darkness of space. This stable configuration gives Webb a steady view, free from the harsh glare of nearby heat. There are no day-night cycles, no sudden changes, only a slow, continuous gaze. Some describe L2 as a place where the telescope can breathe, maintaining its temperature and position with minimal effort. Here, Webb exists like a lantern hanging at the edge of night, calm, distant, and steady. From this balance point, it begins to look back across time. Fact 27. Stabilizing in a gravitational balance. Once at L2, Webb needed to enter a halo orbit, circling gently around an invisible point of equilibrium. This orbit is not like circling a planet. It is more like gliding around a hollow, weightless pocket in space. Small bursts of thrust help maintain the balance, like subtle adjustments a person makes to stay floating in water. Because Webb is so far from Earth, communication signals take time to travel. Instructions are whispered across the void, arriving seconds later, like a conversation spoken across a quiet lake. Yet the telescope holds steady, guided by gentle corrections and deep patience. Here, in this silent balance, it is able to do what it was meant to do: listen to ancient starlight. Fact 28. The telescope's gentle orbit. Webb's orbit around L2 is not fast or forceful. It is subtle, a slow, looping path that traces a wide, graceful curve. The telescope does not circle the Earth, nor does it circle the Sun directly. Instead, it drifts in harmony with both, held in a quiet gravitational embrace. This orbit keeps Webb always facing deep space, while the sun shield remains turned toward the warmth it must avoid. No day or night passes here, only a continuous cosmic dusk where stars never blink out of view. Because of this gentle path, Webb does not strain or struggle against motion. It simply glides, balanced between forces, like a lantern suspended in still air. In this stillness, it can watch the universe unfold without interruption. And so, the telescope settles into the rhythm of the cosmos. Fact 29. Beginning the first alignments. Once Webb reached its stable orbit, its mirrors needed to work as one. Though each of the 18 golden segments had unfolded correctly, they were still positioned like 18 separate eyes. To bring them together into a single, clear focus, the telescope performed a process called wavefront sensing. It pointed at a single bright star, and each mirror segment reflected a slightly different version of that star. Engineers then adjusted each segment by microscopic distances, shifts so tiny they cannot be seen, only measured. Slowly, those scattered points of light began to overlap, merge, and harmonize into one sharp, shining star. It was like tuning the strings of a delicate instrument, each one tightened toward a single perfect note. And when alignment finished, the telescope was no longer many pieces, but one. Fact 30. The star used to sharpen the mirrors. To align its vision, Webb focused on a star called HD 84406, a quiet, modest star in the constellation Ursa Major. It was not chosen for beauty or fame, but for its steadiness. A calm beacon in a peaceful patch of sky. For weeks, Webb returned to this single point of light, studying it again and again. The star became a teacher, offering clarity through consistency. What we see now, galaxies billions of years old, nebulae glowing with newborn stars, planets wrapped in distant skies, all began with this simple act of looking closely at one ordinary star. Sometimes, great discoveries begin with quiet attention, just as rest begins with a single slow breath. Fact 31. The first blurry images. When Webb first opened its eyes, the images it captured were not yet the breathtaking vistas we know today. Instead, they appeared as scattered points, many tiny reflections of the same star, scattered across the field of view. These blurs were not mistakes. They were the starting point of a delicate process. Each reflection came from a different mirror segment, still waiting to be aligned. Engineers studied these blurry patterns like one studies the ripples on a quiet pond, learning how each segment needed to shift and tilt. Slowly, gently, day by day, the patterns began to drift closer together. Though the images were unclear, they held promise, like a sketch before a painting. From this early haze, clarity would soon unfold. Blurriness was simply the first whisper of vision awakening. Fact 32. The moment of perfect focus. The day Webb achieved perfect focus was quiet yet monumental. There was no dramatic fanfare, only a single, sharp star shining on the screen in the control room, clear and steady. The mirrors had aligned so precisely that the light waves reflected by each segment met in perfect harmony. Astronomers described it as watching a golden ear tune itself to the music of the universe. When that star came into focus, every hour, every setback, every careful calculation suddenly made sense. It was a moment of stillness, not celebration loud and bright, but gratitude soft and deep. The telescope was ready. For the first time, humanity had an eye capable of seeing the earliest light in the cosmos, and all that remained was to turn it toward the unknown. Fact 33. The world paused for the first reveal. When Webb's first deep-field image was released, the world fell silent for a moment. The picture showed thousands of galaxies, each one vast, ancient, and full of stars, contained within a small patch of sky, no larger than a grain of sand held at arm's length. Some galaxies were stretched by gravitational lensing, their shapes curved like reflections on rippled water. Others glowed softly in reds and golds, their light having traveled for billions of years. This image was not just beautiful, it was humbling. It reminded us that the universe is far larger, older, and more full of quiet wonder than we could ever fully grasp. And yet, we are part of it. Looking at that image felt like taking a deep, slow breath. Fact 34. The deep field that changed everything. The first deep field image from the James Webb Telescope was not just a photograph. It was a window into time. Captured over long, patient hours of observation, it revealed galaxies so distant that their light began its journey billions of years before Earth even formed. In this one small view, thousands of separate universes of stars appeared, each holding stories we have only begun to imagine. Some galaxies were bright and structured, while others looked like faint smudges, shimmering near the edge of visibility. Yet each one contained countless suns, planets, and perhaps even the first seeds of life. The deep field reminded us that the night sky is not empty. It is full, overflowing, abundant, and all that richness exists in places we have barely begun to touch with our understanding. We fell silent before it, as though we were looking through a keyhole into infinity. Fact 35. A window into 13 billion years. The light Webb captures is ancient, older than our planet, older than our sun, older than the Milky Way itself. When we look at the earliest galaxies through Webb's eyes, we are not seeing them as they are now, but as they were 13 billion years ago, during the earliest chapters of the cosmos. In a very real sense, Webb does not just observe the past, it travels through it. The light has been on its journey since before life began, passing through the fabric of expanding space, stretched thinner and cooler until it can only be seen in infrared. To receive that light is to touch the very beginning of time, to witness the universe learning to shine. It gives us perspective, gently reminding us that every moment, no matter how small, is part of a much larger story. Fact 36. Seeing galaxies as they first awoke before Webb. Astronomers believed early galaxies were small, dim, and simple. But Webb's deep infrared gaze revealed something unexpected. Some of the universe's first galaxies were surprisingly bright, structured, and highly active. These early galaxies were not quiet. They were full of star formation, glowing gas, and swirling dust, places of intense and vibrant creation. This discovery suggested that the universe grew and organized itself faster than we once thought. The first galaxies were not fragile sparks. They were dynamic furnaces of light. In this realization, we gained a deeper sense of how quickly the cosmos came alive. It is like learning that the first dawn was not soft and pale, but radiant and full of color. And beyond these early galaxies, even older mysteries still wait, gently in the dark. Fact 37. The surprise of unexpected brightness. When Webb observed the early universe, astronomers noticed something astonishing. Many of the first galaxies appeared brighter and more massive than expected for their age. These galaxies existed when the cosmos was still very young, yet they shone as though billions of stars were already burning within them. This brightness challenged long-standing models of how quickly stars could form. It suggested that the early universe was a place of rapid creativity, like an artist painting not in slow layers, but in sweeping, confident strokes. The cosmos, even in its infancy, was dynamic and full of bold energy. Instead of gentle, slow beginnings, it may have burst into brilliance far earlier than we imagined. Webb did not just confirm our theories, it pushed them to evolve, reminding us that the universe always holds more than we assume, more than we can predict. Mystery is not an obstacle, it is an invitation. Fact 38. Seeing light from near the beginning of time. Some of the galaxies Webb observes are so distant that their light has traveled across almost the entire history of the universe to reach us. This light began its journey not long after the Big Bang, when space was still expanding into form. As the universe stretched, the light stretched too, lengthening into the soft infrared glow that Webb's golden mirror can feel. It is like receiving a message written billions of years ago, delivered steadily through time. When this ancient light arrives, it is delicate, faint as dust, soft as breath. Yet Webb holds it gently and translates it into color we can see. In these colors are memories, the beginnings of matter, gravity, and the first stirring hum of structure. To witness this light is to touch the earliest morning of everything that has ever been. Fact 39. A new era of astronomy begins. Webb did more than provide new images. It changed the questions we ask. Astronomy shifted from wondering if the first stars and galaxies could be seen to exploring how they formed, what shaped them, and how quickly they came alive. Webb opened a doorway into epochs once considered unreachable, eras hidden behind distance, dust, and time. Now, scientists can study not only where galaxies are, but how they grow, merge, shine, and evolve across cosmic history. It is as though the universe, once silent about its childhood, has begun to share stories, and we are finally able to listen. Fact 40. A new window into cosmic evolution. With Webb's ability to see deep into the past, astronomers can now trace the story of cosmic evolution with extraordinary clarity. We can observe how the earliest stars formed, how they gathered into galaxies, and how those galaxies slowly organized into larger structures, like cities growing across a once empty landscape. The universe did not develop all at once. It unfolded gently, over billions of years, like a long, quiet sunrise. Webb allows us to see snapshots of this process across time, each image showing a different stage in the universe's growth. It is as though the cosmos kept a photo album of its early years, waiting for us to build a telescope gentle enough to open it. Now, with every new observation, we add another still frame to the story of how existence came to be. Fact 41. The web of cosmic structure. When we look at the universe on the largest scales, galaxies are not scattered randomly. They gather into clusters, and those clusters form long, delicate filaments. Vast, curving rivers of stars and matter stretching across unimaginable distances. These filaments weave together into what scientists call the cosmic web, a structure so large that our minds can only grasp it in metaphor. It resembles neural pathways, river deltas, the branching of trees, patterns that echo throughout nature. Webb's deep field vision makes these structures clearer, showing how galaxies are drawn together by invisible threads of gravity and dark matter. In these immense formations, we see a kind of gentle organization, not forced, but emergent, like frost forming quiet lace on glass. The universe grows in patterns of quiet beauty. Fact 42. Spiral galaxies in their infancy. Before Webb, spiral galaxies, like our own Milky Way, were believed to take billions of years to form their elegant, swirling shapes. But Webb has revealed young spiral galaxies that existed when the universe was still very early in its development. These galaxies already display graceful arms, softly curved like the petals of a blooming flower. Their presence suggests that order emerged sooner than we expected, that the cosmos was not only energetic and chaotic in its youth, but also capable of quiet structure. In these spirals, we glimpse the early echoes of our own galaxy's formation. It is like looking at a baby picture of home, familiar, yet filled with wonder at how far we have come. Fact 43. The strange shapes of the early universe. When Webb looks deep into the early universe, it finds galaxies that do not resemble the graceful shapes we are familiar with today. Instead of smooth spirals or soft ellipses, many of the earliest galaxies appear irregular, stretched, twisted, or clustered like drifting clouds of starlight. These galaxies were still learning their form, shaped by collisions, gravity, and the quiet pull of dark matter. Some look like glowing embers scattered in cosmic wind. Others resemble tiny sparks gathering into the beginnings of structure. They are the universe experimenting, trying shapes, trying movement. Over billions of years, these irregular gatherings will settle, swirl, and gently organize themselves into the galaxies we recognize. To see them in these first stages is like seeing handwriting before letters and words, the earliest motions of meaning still forming. Fact 44. Starburst galaxies in fiery bloom. Some galaxies in the early universe are known as starburst galaxies, places where stars are being born at astonishing speed. In these galaxies, gas clouds collapse rapidly, forming new stars one after another, like sparks flaring in a deep furnace. Webb reveals these worlds glowing brightly in infrared, warm nurseries hanging like lanterns in the dark. Though fiery in description, this process is slow and gentle on cosmic scales, each star taking millions of years to ignite. Yet across vast stretches of time, the effect is dramatic. Billions of new suns kindling across the galaxy's spiraled arms and clustered heart. Starburst galaxies remind us that creation can be both calm and immense, like a quiet ocean tide slowly reshaping the shore, grain by grain, into something luminous. Fact 45. Quiet galaxies drifting in the dark. Not all galaxies burn with the intensity of star formation. Some drift through the universe in quiet stillness, their stars old and steady, their gas long spent. These quiescent galaxies, as Webb observes them, are like lanterns whose flames no longer grow brighter, yet continue to glow softly in the night. Their light is gentle, even patient. They remind us that not all beauty is in the moment of becoming. Some beauty lives in the quiet of simply being. These ancient galaxies float through the cosmic web, like calm thoughts passing through the mind before sleep. They are the universe at rest, a soft exhale after long creation. And in their silence, we see a reflection of our own need for stillness. Fact 46. The search for the first galaxies. One of Webb's most profound missions is to find the very first galaxies that ever formed. These galaxies emerged when the universe was still young, filled mostly with hydrogen and helium before heavier elements existed. They were dim, delicate, and surrounded by thick clouds of gas. Webb's infrared vision allows it to peer through this ancient veil, revealing faint glimmers that have traveled billions of years to reach us. Some of these early galaxies are so small they would appear as only a handful of pixels in older telescopes. Yet within them were the beginnings of everything we know. By studying these first assemblies of starlight, we learn how the universe awoke from its earliest darkness. It is like watching the first candles being lit in a vast nighttime hall. Fact 47. Discoveries older than theories predicted. When Webb began sending back its first images, scientists noticed something surprising. Some of the galaxies it detected were older and more developed than our theories had expected them to be at such early times. This suggests that the universe built structure faster than we once believed, that the process of star formation and galaxy growth began almost immediately after the first light appeared. It is as though the cosmos had been eager to create, shaping stars and galaxies with a steady and determined rhythm. This discovery does not break our understanding of the universe, it deepens it. Science grows when we encounter the unexpected, and Webb has given us a gentle reminder that the universe still holds mysteries, still invites us to explore, still asks us to listen closely to its unfolding story. Fact 48. Galaxies colliding in slow motion. Webb has revealed breathtaking images of galaxies merging. Great cosmic cities of stars drifting together, drawn by gravity. But these collisions are not violent in the way we think of impact. They happen slowly, over billions of years, like two clouds gradually interlacing. Stars rarely collide directly. Instead, gravitational tides pull galaxies into new shapes, stretching them into luminous streams and spirals. In these mergers, galaxies exchange gas, trigger waves of star formation, and eventually settle into new, elegant forms. What looks chaotic from afar is actually a graceful dance, long, deliberate, and full of transformation. Even in collision, the universe moves with softness. Fact 49. The birth of clusters and superclusters. Galaxies rarely exist alone. Over billions of years, gravity draws them toward one another, forming clusters, great gatherings of hundreds or even thousands of galaxies. These clusters, in turn, connect into superclusters, enormous structures so vast they stretch across hundreds of millions of light years. Webb allows us to see these great formations when they were young, when the universe was still deciding how to arrange itself. Some appear as faint gatherings, just beginning to coalesce, while others already show bright cores where many galaxies have come together. These clusters are the cities of the cosmos, full of movement and quiet evolution. In watching them grow, we learn how structure arises from emptiness, how connection forms across unimaginable distance. Even the largest patterns in the universe began as something small, a gentle gathering of light in the dark. Fact 50. The invisible threads of dark matter. The galaxies we see are only part of the cosmic story. They move, gather, and form shapes because of something unseen. Dark matter, a mysterious substance that does not emit or reflect light, yet exerts gravity. Webb helps us trace dark matter not by observing it directly, but by observing how galaxies bend and curve in its presence. Clusters of galaxies act like lenses, bending the light behind them, a phenomenon called gravitational lensing. When Webb sees galaxies stretched into arcs or shimmering duplicates, it is witnessing dark matter's silent influence. These distortions reveal an invisible framework, a vast, delicate scaffolding on which galaxies rest and grow. The universe, it turns out, is shaped by something we cannot see, yet feel through motion and form. Like the wind shaping dunes, dark matter shapes the stars. Fact 51. The Pillars of Creation. Revisited. One of Webb's most moving images is its infrared view of the Pillars of Creation, towering columns of gas and dust in the Eagle Nebula. Hubble first revealed these pillars decades ago, showing their dramatic shape. But Webb's infrared gaze looks through the dust, revealing stars being born inside, softly glowing like embers in a quiet hearth. The pillars stretch like mountains suspended in space, their surfaces sculpted by starlight over millions of years. Inside them, new stars gather material, growing slowly, silently. It is a place of beginnings, where starlight takes its first breath. Seeing the pillars again through Webb is like hearing a familiar song played on a gentler instrument, deeper, warmer, more intimate. Fact 52. The Cosmic Cliffs of Carina. One of Webb's most breathtaking views is of the Carina Nebula, where massive clouds of gas and dust rise like mountains suspended in open space. In visible light, this region appears dramatic and opaque, but Webb's infrared eyes reveal the gentle glow of stars forming deep within the clouds. These towering shapes are not solid. They are delicate wisps of gas sculpted by starlight over millions of years. Young stars at their peaks send out winds of energy, slowly shaping the clouds into new forms, always changing, always becoming. The scene feels like a landscape in soft twilight, yet it spans light years across. The Carina Nebula is a nursery of suns, a cradle of light. To witness it through Webb is to see creation in motion, steady and silent as breath. Fact 53. The Phantom Light of Dying Stars. Webb also observes stars at the end of their lives, when they shed their outer layers and leave behind glowing shells of gas called planetary nebulae. These nebulae are not explosive endings, but gentle transitions, like a lantern dimming as the flame settles. Webb's infrared gaze shows these shells with new clarity, revealing delicate, layered patterns shaped over thousands of years. Inside many of them lies a white dwarf, a quiet, cooling ember of a star that once burned brightly. The nebula continues to drift outward, expanding slowly into space, eventually blending into the interstellar clouds from which new stars will someday form. Even in ending, stars contribute to future beginnings. Their light is never truly lost, only transformed into new possibility. Fact 54. Stellar nurseries. Glowing and infrared star formation happens inside cold, dense clouds of gas where visible light cannot escape. To our eyes, these regions appear dark, like clouds without stars. But Webb sees warmth, not light. It reads the faint heat of gas collapsing into new suns, revealing star nurseries glowing in soft reds and golds. These nurseries are places of slow, steady change. A star may take millions of years to form, quietly gathering material, pulling itself into being through gravity's gentle insistence. Webb's images of these nurseries feel tender, like glimpsing a candle in a sheltered room. They remind us that creation can be slow, hidden, and patient, and still full of wonder. Fact 55. The red dust clouds of formation. The earliest stages of star formation happen inside dense clouds of red dust, so thick that visible light cannot escape. To ordinary telescopes, these clouds appear as shadows, opaque shapes blocking the stars behind them. But Webb, seeing in the infrared, reveals what lies inside. Slow swirls of material gathering under gravity's patient pull. Tiny pockets of gas warm as they collapse inward, glowing softly with the heat of new beginnings. These red-veiled regions are not empty or quiet. They are full of quiet movement, like tides turning beneath the surface of the sea. Every star that has ever shone, including our sun, began as one of these warm, hidden embers. Webb allows us to watch these embers brighten, slowly, across thousands of years of cosmic time. It is like witnessing the universe take its first, gentle breaths. Fact 56. Stars forming, like slow breathing. The birth of a star is a gradual rhythm, an expansion and contraction repeated over vast spans of time. Clouds of gas condense inward, then release heat outward, then condense again. This cycle continues like breathing, slow and steady, across millions of years. Only when the core becomes hot and dense enough does nuclear fusion begin, the moment the star awakens and begins to shine. Webb captures these earliest phases not through visible light, but through the faint warmth of the gas and dust involved. Even the smallest fluctuations in temperature tell the story of a star's growth. To see this process is to realize that creation is not sudden. It is gentle, patient, and full of quiet persistence. The stars remind us that light comes slowly, but it arrives. Fact 57. The gentle collapse of gas into light. In every star's beginning, gravity performs a quiet miracle. What begins as ordinary gas, scattered, cool, drifting, is slowly drawn inward until it becomes dense enough to glow. This transformation is not explosive, but inevitable, like water finding its path down a hillside. Webb observes this process in exquisite detail, showing how strands of gas fold inward, how shock waves ripple through clouds, how new stars emerge in clusters like constellations waiting to be named. Each star is a testament to time, to the universe's ability to shape itself with patience rather than force. As the gas collapses and the first light forms, the surrounding clouds glow like lanterns in the dark. Birth in the cosmos is quiet, yet absolutely profound. Fact 58. Supernova, remnants as cosmic gardens. When a massive star reaches the end of its life, it does not simply fade. It expands, brightens, and then releases its outer layers into space in a slow, majestic outpouring. This event is called a supernova, but Webb shows us a softer side of this transformation. In infrared, the remnants of a star look like petals of glowing gas, drifting outward to form intricate, colorful shapes. The elements released, carbon, oxygen, iron, sprinkle into the cosmic medium, where they will one day become part of new stars, planets, and perhaps living beings. Supernova remnants are not destruction. They are renewal. They are the gardens of the universe, where the seeds of future worlds are sown. Webb lets us witness this quiet exchange, the passing of light from one generation of stars to the next. Fact 59. The death of stars, seeding new worlds. Every time a star dies, the universe becomes richer. The heavy elements forged in its core during its lifetime are released into space, mixing with vast clouds of gas. Over millions of years, these enriched clouds compress into new stars and sometimes into planets. The iron in your blood, the calcium in your bones, the oxygen you breathe, All of it was created inside stars that lived and died long before Earth existed. Webb helps us trace this cycle, the ongoing conversation between light and matter, beginning and ending, creation and quiet return. This understanding brings comfort. We are literally made of stardust. We are part of the universe's story, not separate from it. When we look at the stars, we are, in a way, looking at our own origins. Fact 60. The quiet cycles of stellar life. The life of a star is measured not in years, but in millions or billions of years. From its birth in a red cloud, to its long, steady glow, to its gentle release back into space, a star lives in slow rhythm. Webb allows us to see these phases not as isolated moments, but as parts of a continuous cycle. Stars are born, shine, and return their material to the cosmos. And from that material, new stars and worlds emerge. There is no true beginning and no final end. Only continuity, expressed as light. This cycle reminds us that change is not something to fear. It is natural, quiet, ongoing, and deeply beautiful. The universe breathes through the lives of its stars. Fact 61. Measuring worlds by their shadows. Webb has a quiet way of discovering distant planets. It watches for shadows. When a planet passes in front of its star, even from countless light years away, the star's brightness dims by the smallest amount. This dimming is so subtle it would be invisible to our eyes, but Webb's instruments are sensitive enough to detect it with extraordinary precision. By studying the shape and timing of this shadow, scientists can learn the planet's size, orbit, and whether it is rocky or gaseous. It is a way of knowing a world not by seeing it directly, but by seeing how it changes the light around it. In this method, there is something poetic. We learn about distant worlds by watching the soft flicker of a star, the light breathing ever so gently. Fact 62. Reading. Atmospheres from LightWebb does not simply detect distant planets. It can read the chemistry of their atmospheres using a method called spectroscopy. When starlight passes through a planet's atmosphere, certain wavelengths are absorbed by the gases present. Webb spreads this light into a spectrum, revealing subtle patterns, dips and rises in color that encode the identity of molecules. From this, we can detect water vapor, methane, carbon dioxide, and other building blocks of habitability. It is like decoding a message carried across space by light itself. This means we are no longer just discovering that planets exist. We are beginning to understand what they are like, how they might feel, and whether they could support life. The universe becomes not just vast, but familiar, full of worlds, with skies and weather and the quiet possibility of home. Fact 63. Water vapor in distant skies. One of Webb's most hopeful discoveries is the detection of water vapor in the atmospheres of planets orbiting distant stars. This does not mean oceans or rain, but it does mean that somewhere, in the deep expanse of space, there are worlds where water exists as part of the natural sky. Some of these planets are scorching hot, others cold and dim, but the presence of water tells us that the ingredients for life are not unique to Earth. Water is gentle. It carves rivers, nourishes cells, lifts clouds into the sky. To find it light years away is to find a familiar whisper in a vast and unknown night. It reminds us that the universe does not merely allow life, it invites it. Fact 64. The search for carbon molecules. Carbon is one of the quiet foundations of life as we know it. It forms the structure of cells, the shape of proteins, the gentle framework of memory and breath. Webb's instruments are finely tuned to detect carbon-based molecules in the atmospheres of distant worlds. molecules such as methane, carbon monoxide, and more complex organic compounds. Finding these does not prove life, but it suggests that the building blocks of life may be common, not rare. Like seeds scattered across a vast field, waiting for the right conditions to take root, Webb listens for these molecules in the faint light of exoplanet transits, reading the smallest details of color and glow. In doing so, it helps us ask a tender question. Not is life possible elsewhere, but how many ways might the universe already be living? Fact 65. Planets larger than imagination. Among the countless worlds Webb observes are super Jupiters, planets far larger than anything in our solar system. Some of these giants are so big they could hold dozens of Earths within them, wrapped in swirling storms and layered clouds. Many orbit their stars up close, glowing with heat, shimmering like embers in a cosmic hearth. Others drift farther, cold and serene, their gases calm and layered like quiet fog. Webb can read their atmospheric temperatures, detect complex molecules, and even map cloud patterns. These enormous worlds remind us that the universe does not confine itself to our familiar shapes. It experiments. It plays with scale. It paints on canvases wider than our minds can easily hold. And within these vast forms may lie moons, places with oceans, storms, and perhaps quiet shoreline dawns. Fact 66. Tiny rocky worlds with quiet suns. Beyond the giant planets, Webb also studies rocky worlds not much larger than Earth. Some orbit small, cool stars known as red dwarfs, stars that burn steadily for trillions of years, offering gentle, lasting warmth. These systems are calm compared to the bright blaze of stars like our sun. If life were to arise there, it would have time, great stretches of time, to grow, change, and flourish. Webb cannot yet see the surfaces of these small planets, but it can read their skies, searching for signs of water, breathable air, or chemistry that hints at living processes. To know that small, Earth-like worlds are common is to know that home is not unique. The universe may hold many quiet harbors, places where someone or something might look back at the same stars. Fact 67. Gas giants with rings of ice. Not all planets with rings are like Saturn, delicate, golden, familiar. Webb has revealed gas giants around distant stars that also wear rings, some far larger, wider, and more intricate than anything found in our own solar system. These rings are made of dust, ice crystals, and shattered moon fragments, drifting in slow, majestic loops around their parent planets. Through infrared light, Webb sees the faint glow of sunlight scattering through the tiny particles, forming halos that shimmer like frozen halos in deep night. The sight reminds us that beauty is not rare in the universe. It is a natural outcome, a quiet expression of gravity and time. Rings form when systems shift, when moons break, when dust settles into arcs of balance. Even far from home, the universe arranges itself into patterns of grace. Fact 68. Super Earths wrapped in haze. Some planets Webb observes are called super Earths, rocky worlds larger than our own, yet smaller than gas giants. Many of these planets are enveloped in thick atmospheres, layers of haze and cloud that scatter light into soft colors. Their compositions vary. Some may have oceans beneath their skies. Others may be covered in continents of rock and metallic plains. Webb studies how starlight filters through these hazy atmospheres, searching for chemical traces that whisper of temperature, pressure, or even potential habitability. We cannot see their surfaces directly, but we can feel their presence through the patterns of light they leave behind. These worlds suggest that Earth is not the only way a planet can be, that life, if it exists elsewhere, may rise beneath unfamiliar skies, under colors we cannot yet imagine. Fact 69. Worlds locked to one side of their stars. Many planets discovered by Webb orbit so closely to their stars that they become tidally locked. One side always facing the star, the other always turned to night. On the day side, temperatures can be scorching, with skies blazing under endless noon. On the night side, eternal darkness cools the atmosphere into stillness. Yet, in between, in the gentle terminator zone, where day meets night, conditions may be mild, balanced, and calm. Some scientists believe that these twilight bands could be the most promising places for life to exist beyond Earth, a world where every sunrise is permanent and every horizon glows softly. Webb searches these bands for signs of skies that breathe. Fact 70. The search for breathable air. One of Webb's most delicate missions is to look for atmospheres that could support life. In spectroscopy, breathable air reveals itself not in shapes or colors, but in patterns of absorbed light. Tiny dips in a spectrum, each one corresponding to a known molecule: nitrogen, oxygen, carbon dioxide, ozone. These are the quiet signatures we listen for. So far, Webb has detected water vapor, carbon dioxide, and even hints of methane on distant worlds. But the search continues for a true balance, a composition that feels familiar, like home. This search is not rushed. It is a slow, steady listening, a way of asking the universe a gentle question. Are we alone? And the universe, patient and vast, seems to be answering in whispers, not yet clear, but close, like a dream almost remembered upon waking. Fact 71. JWST looks at Jupiter's aurora. Webb does not only look far into the past, it also turns its gaze toward our own solar system, seeing familiar planets with new quiet clarity. When Webb observed Jupiter, it revealed shimmering auroras at the poles, glowing like curtains of soft fire. These lights dance where the planet's magnetic field meets charged particles from the sun. In infrared, they appear not just bright, but intricate, shaped by invisible rivers of energy flowing through Jupiter's atmosphere. The planet's great red spot, storms, and bands all showed subtle temperature patterns and delicate movements that are usually hidden. Seeing Jupiter in this gentle, glowing light reminds us that wonder does not exist only in far galaxies. It lives close to home, in the skies of worlds we know well. Even the familiar can become new again. Fact 72. The bands and storms, in new detail. Jupiter's atmosphere is a world of storms. Great rotating systems, larger than entire continents on Earth. Webb's infrared view allows scientists to see heat moving through these bands, revealing how winds and cloud layers interact deep below the surface of the visible atmosphere. Some regions glow softly with warmth rising from within the planet. Others appear cooler, drifting in wide, slow currents. These patterns show that Jupiter is not simply chaotic. It is organized, layered, and rhythmic, like a deep ocean with currents flowing beneath the waves. Webb lets us see these hidden layers, unveiling the structure of storms that have been spinning for centuries. In this view, Jupiter is not just a gas giant. It is a living, breathing world of continuous motion, always changing, always flowing. Fact 73. Saturn's hidden temperature patterns. When Webb observed Saturn, it did not focus on the rings alone, though they shimmer like pale silver in starlight. Instead, Webb looked deeper. into the planet's atmosphere, where temperature shifts create soft, flowing bands of cloud and haze. In infrared light, these temperature differences become visible, spreading across Saturn like brushstrokes of warm gold and cool violet. Some regions glow faintly with rising heat. Others appear calm and shadowed, where cooler air settles. The result is a portrait not of chaos, but of rhythm, a slow planetary breathing. Saturn's rings, too, reveal faint structure, clumps, gaps, and icy fragments drifting in quiet orbit. Through Webb, we see Saturn not as a distant ornament in the solar system, but as a world with weather, motion, and quiet, ever-changing moods. Even in stillness, it moves. Fact 74. Neptune's blue glow. Reimagined. Neptune has always appeared to us as a deep, mysterious blue, a world of swirling winds and distant frost. Webb's infrared gaze transforms that familiar blue into something more subtle, more layered. The planet's cold methane atmosphere reflects light differently in infrared, revealing cloud bands, storms, and a soft halo around its edges. Neptune's thin, ghost-like rings, once barely detectable, appear more clearly, encircling the planet like delicate jewelry made of ice and dust. Even the moon, Triton, glows brightly in Webb's view, its icy surface reflecting sunlight in shimmering silver. To see Neptune in this new light is to understand that even the farthest reaches of our home system are alive with texture and quiet beauty. The cold does not mean empty, it means serene. Fact 75. Uranus and its secret rings. Uranus has often been overlooked, faint, distant, and softly spinning on its side, tilted almost completely onto its axis. But Webb reveals Uranus as a pale, opalescent globe, surrounded by rings that glimmer gently, some thick, some faint, like whispers of ice suspended in the dark. The planet's clouds appear as subtle bright patches, marking storms in an atmosphere colder than almost anywhere else in the solar system. This sideways world is unique. Its seasons last decades, its poles tip toward and away from the sun in long, slow arcs. Webb's view shows Uranus not as an afterthought, but as a quiet, elegant mystery, a planet shaped by slow time and delicate balance. Sometimes beauty is not bold, it is patient, waiting gently to be seen. Fact 76. Comets as ancient messengers. Comets are some of the oldest travelers in our solar system, icy wanderers that formed when the sun was young. Webb observes comets not as bright streaks, but as glowing cores surrounded by soft halos of vapor. As they drift closer to the sun, the warmth gently releases trapped gases and dust, forming long flowing tails that stretch across millions of kilometers. In infrared light, Webb can see the chemical signatures inside these vapors: water, carbon compounds, traces of organic molecules. These materials are the same ingredients that once rained down upon early Earth, helping to shape oceans and perhaps even the first stirrings of life. Comets are storytellers, carrying memories of the solar system's beginning. Through Webb, we read those memories slowly, like pages in a book written in starlight and ice. Fact 77. Asteroids as silent archives. Asteroids are not merely rocks drifting through space. They are archives, preserving the raw materials from which planets were formed. Webb can analyze the mineral fingerprints reflected from their surfaces, detecting metals, silicates, and carbon-rich compounds. Some asteroids are dense and metallic, pieces of ancient planetary cores. Others are porous and dusty, more like untouched cosmic clay. Together, they carry the quiet history of our solar system: how it formed, how it changed, what ingredients were once available. Unlike planets, Asteroids do not melt or erase their past. They hold time gently, unchanged for billions of years. When Webb studies an asteroid, it is not looking into the distant universe, but into the deep past of our own home, preserved in silence. Fact 78. Kuiper Belt. Objects in the far cold. Far beyond Neptune lies the Kuiper Belt, a vast ring of icy worlds drifting in the cold darkness. Some are small and irregular, others surprisingly large and spherical, like Pluto and its neighbors. This region is so distant that sunlight arrives faint and slow, like a whisper. Webb's infrared vision reveals these frozen worlds with new clarity, showing subtle color differences, thin atmospheres, and surfaces shaped by slow, ancient frost. In the Kuiper Belt, everything happens gently. Erosion takes eons, and change is measured in ages. These worlds are remnants of the solar system's earliest construction, untouched, pristine, and quiet. To see them is to look back to a time before Earth's oceans formed, before mountains rose, before life opened its first eyes. They are the winter memory of our cosmic home. Fact 79. Stars in other galaxies. Seen individually. Most telescopes can only see the combined glow of billions of stars when looking at distant galaxies. But Webb is so sensitive that in some galaxies, it can distinguish individual stars, like tiny lanterns shining across millions of light years. Each star carries its own story. Some are young and bright, others ancient and fading. By studying their light, Webb can determine their temperature, age, and even how much heavier elements they contain. This allows astronomers to understand how star formation unfolds differently in different parts of the universe. It is like walking into a city at night and noticing not just the skyline, but each window lit with a life inside. Webb helps us realize that every galaxy is full of quiet neighborhoods of starlight, countless homes of light in the dark. Fact 80. Star clusters, like cosmic cities. In many galaxies, stars form together in great clusters. Thousands of suns gathered closely in a single region of space. These clusters glow like jeweled knots in the fabric of the sky, shining more brightly than anything around them. Webb's infrared view reveals the shapes of these clusters with extraordinary clarity, showing how stars are arranged, how they drift, and how they evolve together. Some clusters are dense and radiant, like cities full of life and activity. Others are more spread out, like small towns scattered under wide open sky. By studying clusters, astronomers learn how stars influence one another, how gravity binds them, how winds sculpt them, how their light shapes the surrounding clouds. Clusters remind us that even in the vastness of space, togetherness is common. Stars are born in company. Fact 81. Tracing galaxy histories through starlight. Just as trees carry rings marking each year of growth, galaxies carry signatures in their starlight that reveal their past. Webb can read these signatures: the ages of stars, the presence of dust, the glow of ancient populations hidden beneath newer ones. This allows scientists to trace the timeline of a galaxy's life, when it formed stars quickly, when it rested, when it merged with neighbors, and when it changed shape. A galaxy becomes not just an image, but a story, a long and winding history written in light. Through Webb, we learn that galaxies grow, mature, and transform over billions of years, quietly responding to their environment. Their evolution is slow, graceful, and deeply patient. Like everything in the universe, they change, but never in haste. Fact 82. The quiet hearts of galaxies. At the center of nearly every galaxy, including our own, lies a supermassive black hole. These black holes are not always violent or consuming. Many rest quietly, influencing their galaxies through gentle gravity rather than force. Webb's infrared eyes can peer into the dusty centers of galaxies where visible light cannot reach, revealing how stars orbit, swirl, and gather near these hidden hearts. It sees the warm glow of gas spiraling inward, not in chaos, but in slow, elegant curves. The black hole itself cannot be seen. It is a silence, a pause in the fabric of space, but the light around it reveals its presence, like wind revealing shape in tall grass. Through Webb, we learn that even the darkest places in the universe are full of movement, full of story, full of quiet gravity. Fact 83. Light bending. Around the invisible one of Webb's most profound abilities is observing gravitational lensing, the bending of light by massive objects like galaxy clusters. When light travels past such mass, it curves, stretching images of background galaxies into arcs and ripples. To the eye, these arcs look like cosmic brushstrokes, delicate and dreamlike. But beneath their beauty lies astonishing information. They reveal the distribution of dark matter, the unseen structure shaping the universe. These distortions turn space into a natural telescope, magnifying galaxies so distant that even Webb alone couldn't have seen them. In this way, the universe helps us see itself, one part acting as the lens for another. Light bends, and the past is revealed, softly and elegantly. The cosmos is reflective, always showing more if we learn to look gently. Fact 84. Black holes. Feeding in silence. Not all black holes announce themselves with bright jets or swirling storms of heated gas. Some feed quietly, drawing matter inward so slowly that the surrounding space appears calm. Webb can detect the faint warmth of this process. Soft infrared signatures of gas gradually heating as it approaches the event horizon. These quiet black holes are like embers rather than flames, glowing faintly in long, slow cycles. Their influence shapes galaxies in subtle ways, guiding the formation of stars and the movement of interstellar gas. In stillness, they are powerful. In silence, they reshape the cosmos. Webb teaches us that not all forces are loud. Some of the greatest are gentle, steady, and almost invisible. Fact 85. The chemistry of life. Written in light, Webb has a unique talent. It reads light as language. When light passes through gas or reflects from the surface of a world, it carries chemical signatures with it. Webb breaks this light into delicate rainbows of data, where every tiny dip or rise corresponds to a particular molecule. Among these signatures are molecules associated with life, not life itself, but the conditions life needs: water, carbon compounds, oxygen-bearing gases, and even the subtle haze left behind by biological processes. The telescope does not leap to conclusions. It listens. Each spectrum is like the quiet page of a diary written across light years. Webb helps us read these pages gently, patiently, without forcing meaning too quickly. The universe speaks in slow patterns, and we are just learning to understand the grammar of stars and atmospheres. Fact 86. The soft glow of organic molecules in space. Some of the most intriguing chemicals Webb detects are complex organic molecules drifting in interstellar clouds. These molecules form on tiny grains of dust, frozen together in the quiet cold between stars. When a young star warms its surrounding cloud, these molecules begin to move, combine, and evolve. In Webb's infrared vision, they appear as faint, warm glows, subtle hints of chemistry stirring in darkness. These are not signs of life, but signs of readiness for life. The ingredients that can form amino acids, proteins, and the delicate machinery of living cells. It reminds us that the universe does not hoard the materials for living things. It scatters them generously, like seeds carried on a soft wind. Life, if it arises elsewhere, may feel less like rarity and more like a quiet unfolding. Fact 87. The gentle search for biosignatures. A biosignature is a pattern that suggests life may be present. Not proof, but possibility. Webb searches for these patterns with deep patience, observing a planet through many transits, building up clear, careful data. The telescope watches how gases change with heat, season, star brightness, and time. Life, if present, might leave behind rhythms, repeating patterns in the makeup of a planet's air. These rhythms would be soft, like breath. Webb's search is slow, precise, and full of wonder. We are not expecting a sudden announcement. We are listening for harmony, the kind of balance that only living worlds tend to create. In this search, hope becomes gentle, grounded, and steady, a quiet openness to possibility. Fact 88. Time is Webb's silent companion. Every one of Webb's discoveries depends on time, long exposures, slow alignments, patient analysis. Unlike human senses, which notice what is bright and immediate, Webb is tuned to what is faint and ancient. It gathers light not in a moment, but across hours or days, letting the dimmest signals slowly reveal themselves. This patience allows Webb to reach deeper into space than any telescope before it, peeling back layers of cosmic history, one quiet photon at a time. Time is not a challenge for Webb. It is the medium in which it works. In this way, Webb reminds us that understanding is not rushed. It grows slowly, like the tide rising grain by grain along the shore. Some of the most profound insights come not from force, but from gentle waiting. The universe reveals itself to those who take time to listen. Fact 89. Science as a collective dream. The James Webb Space Telescope is not the creation of a single nation or a single team. Thousands of people across the world contributed. Scientists, engineers, mathematicians, artists, welders, programmers, and dreamers. They worked for decades, sometimes without knowing if the telescope would ever launch. The effort cost patience, dedication, and a kind of quiet faith. Faith that seeking knowledge is worth the time it takes. Webb represents a shared dream, a belief that understanding the universe enriches everyone, no matter where they live or what language they speak. When we look at the images Webb sends back, we are looking at the result of human cooperation, a reminder that curiosity can unite us. The stars do not belong to any one person. They belong to all who wonder. Fact 90. A new age of cosmic understanding. With Webb, astronomy has entered a new era. One defined not just by what we see, but by what we can measure, interpret, and feel. The telescope allows us to watch galaxies forming, stars being born, and worlds unfolding in their quiet rhythms. Each new observation changes our understanding, not with shock, but with slow, widening awareness. We are no longer asking simply what is out there. We are asking how, when, and why the universe took the shape we now see. This shift is gentle, like dawn light slowly revealing the landscape of the world. Webb has not just expanded our view, it has deepened our relationship with the cosmos, making it feel less distant, more continuous with our own existence. We are part of the same unfolding story. Fact 91. Watching the universe. Slow its expansion. The universe has been expanding since the first moment of creation, but the rate of that expansion changes over time. Webb studies distant galaxies at various ages, comparing how far their light has traveled to how fast they are moving away. By doing this, it helps scientists understand how the universe's expansion has slowed, sped up, and shifted across billions of years. This work touches something subtle and profound: the influence of dark energy, a mysterious force that causes space to stretch. Webb cannot see dark energy directly, but it can watch its effects across time, like watching a distant sailboat move under invisible wind. The information Webb gathers helps us understand the universe's future, whether it will expand forever, drift slowly into stillness, or evolve in ways we cannot yet imagine. Webb listens to the slow heartbeat of cosmic time. Fact 92. The universe preserves its memory in light. Every galaxy, every nebula, every drifting cluster of stars holds memory, not written in words, but in light. Light carries information about where it has been, how far it has traveled, and what it has passed through. Webb collects these memories gently, like pressed flowers saved in a book. When we study ancient light, we are learning the story of the universe itself. The first sparks of starlight, the first heavy elements forged, the early shaping of galaxies. All of it remains encoded in the soft glow that still drifts across space. To understand this is to realize that nothing truly disappears. Transformation is constant, but memory remains. The universe remembers its beginnings, and Webb helps us translate those recollections into understanding, into wonder, into rest. Fact 93. The telescope that works in silence. Webb performs all of its observations silently, drifting in the darkness at Lagrange point 2. There is no sound in space, only motion, light, and quiet. The telescope does not move quickly or forcefully. It shifts with tiny, nearly invisible adjustments. Its mirrors hold still, aligned to a billionth of a meter, sensitive enough to detect a single grain of warmth across galaxies. Everything Webb does is gentle. It listens rather than reaches. It receives rather than takes. It is a reminder that great discovery can happen without noise, without urgency, without hardness. The universe does not shout its secrets, it whispers them. And Webb is an instrument built to hear whispers. Fact 94. A legacy that will outlive us. The James Webb Space Telescope is designed to observe for decades, long enough that many of the scientists who helped build it will watch it age alongside their own lives. Its discoveries will continue to deepen and unfold long after today's questions have turned into tomorrow's understandings. Children who are only learning to read now will grow up in a world shaped by Webb's insights. They may one day speak casually about the first galaxies, the chemistry of distant atmospheres, the rhythms of stars forming in quiet clouds, things that, before Webb, were invisible to us. In this way, Webb is not only a telescope, it is a gift to the future, a message that curiosity endures, that wonder continues, and that every generation has more to discover. The universe is vast enough for all of us. Fact 95. The telescope that will change. Questions, not just answers. Webb will answer many questions, but its greatest power lies in the new questions it inspires. Every time it reveals something unexpected, it shifts our understanding of what is possible. Perhaps early galaxies formed faster than we knew. Perhaps life-supporting chemistry is more common than we believed. Perhaps the universe is more dynamic, more creative, more patient than our theories suggest. Science is not simply about accumulating knowledge. It is about expanding imagination. Webb teaches us to ask more softly, more curiously, without rushing towards certainty. Every discovery opens a doorway. Every doorway leads to another horizon. We explore not to reach an end, but to continue wondering together. Fact 96, a symbol of humanity. Looking up. There is something deeply human about building a telescope and pointing it toward the stars. It speaks to a longing older than language, a quiet desire to understand where we come from and where we are going. Webb floats in silence, but it represents a shared gaze, a global act of looking upward in unity. When we see its images, we feel something slow and gentle inside us, the realization that we are small, but part of something vast and beautiful. The night sky is not empty. It is full of connection. Webb reminds us that wonder is not childish. It is essential. We rest better when we remember that we belong to the universe, and the universe belongs to no one, yet welcomes everyone. Fact 97. Webb as a bridge between generations. The James Webb Space Telescope stands at a beautiful crossroads in time. It carries the dreams of those who studied the universe decades ago, while opening doorways for those who will explore it in the centuries to come. Older astronomers who once wondered if the early universe could ever be observed now see their hopes realized. Younger scientists, students, and dreamers look at Webb's images and feel the spark of curiosity that may guide their entire lives. In this way, Webb is both memory and invitation, a bridge across time. It shows us that knowledge is something we share and expand together, slowly, generation by generation. Even when we are gone, wonder continues. The stars keep calling, and the journey does not end. It only widens. Fact 98. The telescope that sees what eyes cannot web does not see the universe the way we do. Its eyes are tuned to infrared light, wavelengths longer and softer than visible light, the gentle warmth that objects release as they exist. Where our eyes see darkness, Webb sees glow. Where our eyes see clouds of dust, Webb sees the stars forming inside them. Where our eyes see faint smudges, Webb sees galaxies all the way back to the dawn of time. This reminds us that reality is always larger than what we can immediately perceive. Sometimes, understanding requires a different kind of seeing, a quiet seeing, a patient seeing. Webb teaches us that beauty is not always obvious. Sometimes it is hidden, waiting for the right kind of attention. Fact 99. A quiet companion to the human story. As Webb orbits silently at Lagrange point 2, it is always there. Not fleeting, not temporary, but constant. While we live our days, working, resting, hoping, learning, Webb continues to look outward, gathering the faint light of ancient stars. It does not rush. It does not tire. Its work is steady, gentle, continuous. In a way, Webb is a companion, a reminder that beyond the concerns of daily life, the universe endures in quiet beauty. We are small, yes, but not insignificant. We are part of something vast, ancient, and ongoing. And that knowledge can be comforting, like a deep breath at the end of the day. Fact 100. The universe as a place to rest. In the end, the James Webb Space Telescope reminds us of something simple and profound. The universe is not just a place of vast distances and ancient light. It is a place to rest the mind. When we look at the deep field, or the gentle glow of a forming star, or the quiet curve of a distant planet's atmosphere, something inside us softens. We realize that the universe does not hurry. It unfolds patiently, steadily, with time enough for everything. This realization brings peace. It reminds us that we too can slow down. We too are part of something timeless. We do not need to know everything now. We only need to breathe and look up and remember that we belong to the same quiet starlight that shines across billions of years. And as our journey comes to a gentle close, I hope you found a sense of calm among the stars tonight. If drifting through these sleepy facts has brought you rest, I invite you to like the video, subscribe, and share in the comments which cosmic wonder you'd love to fall asleep to next. When you're ready to continue dreaming, just tap the next Sleepy Astronaut video and let your quiet voyage through the universe unfold a little farther. For now, let your breathing soften, your thoughts grow light, and your body settle into stillness. Thank you for traveling with me. Sweet dreams, and see you among the stars.